Yesterday, I received an interesting question from one of the viewers, and along with that, he had sent a link to a YouTube video that showed a mechanism like this. The mechanism consisted of a disc like this green one here with two slots at right angles as shown. Engaging with these two slots were two sliders. I have shown them in orange, and on those sliders we have two pins with which we have attached this rigid link to these sliders. The motion of this mechanism that was shown was something like this, that this light blue link which is connecting the two sliders was all the time keeping upright as the disc rotated. You will obviously recognize this as some variation of or some extension of a double slider. In fact, if we stop it in some position like this, it is indeed a double slider, elliptical trammel to be precise. So here we have a disc which is fixed, suppose, and it has these two slots engaging in those. There are two sliders. Attached to those sliders are this link. Then this point here is going to trace an ellipse. So this is a elliptical trammel. Now the question the user had sent was, is this mechanism possible? The answer is yes. The mechanism as such is possible. One can make this mechanism, and there is nothing difficult about it or impossible about it. But if the question were, is the motion possible, then the answer is no. At least not without some modification to what you are currently seeing on the screen. And that is because we are starting with a classic double slider. So it already has 1 degree of freedom. On top of that, we are making this fixed link rotate. So we are adding a motion, we are adding a degree of freedom, and that can't be done unless you add some link. So there is a fixed link added to this mechanism on which this disc starts rotating. Now, as you know, every link that we add to our mechanism adds 3 degrees of freedom. But we are also going to add a revolute pair, that is the bearing in which this green disc would rotate, so which will absorb 2 degrees of freedom. So in all, we are adding 3 degrees and removing 2. So there is a net addition of a degree of freedom. So the mechanism that was shown in the video is actually a 2 degree of freedom mechanism. One was obvious, the rotation of the disc. But the one which was suppressed is the rotation of this blue link. So although it is possible to artificially animate a mechanism like this, in reality, with physical links, you will not be able to achieve that motion just by using these many links. We'll have to have some extra. So let us investigate what kind of extra links or constraints that we need for achieving this motion. That is, the motion that keeps this blue link always upright. If that is so, this link is in translation, and in translation, every point on the rigid body traces an identical path. So let us take a simple point on this particular link and investigate its motion. For that, we'll go back to our ordinary double slider. So here is that wall, floor, and a sliding ladder problem, which is nothing but a double slider. And you know, the midpoint of this link or the ladder always traces a circle, while every other point traces a ellipse, except for the two sliders, of course. So if that is so, here if we take the point midway between these two pins, it must be tracing a circle with respect to this point. And if it is tracing a circle, then every other point on this link must also be tracing a circle. So let us see if this hypothesis is true. So I'll set it in motion and I'll try to trace the path here, and it is indeed a circle. So if it is tracing a circular path, or we want it to trace a circular path, that's very easy to do. All we need is connecting a crank. So if we connect a crank like this and provide a support for this whole mechanism, we are in business. So let us take a look at our final mechanism here in 3D. This is how the mechanism would look, and let us set this in motion. So this is the kind of motion that we would get. And to achieve this motion, let us take a stock what we have added. We have added the support, that is one extra link, the crank, the second extra link. So 2 links have been added, which would bring 6 degrees of freedom. While we have also added a pin here at the crank, the second pin here connecting these two, and a third pin here that is nothing but the bearing. So 3 revolute pairs added, which would remove the 6 degrees of freedom. So there is no net addition of degrees of freedom. This still is 1 degree of freedom mechanism, but this is a 6 bar.